Welcome everyone to the first lecture on system security. We have in previous weeks talked about network security, which is about how you secure yourself against attacks on your communication on the network. But this week we go into in-house in the system, and we look at how do we have security against, well, of course, attacks from the outside, but also attacks even from our own users. And to have any chance of establishing security in such a situation, we need always a very really fundamental concept called the trusted computing base, also known as TCB. So this basically is the part of the system that you trust cannot be attacked even by the own users, even by your own users in the system. If you think about it, it's quite clear that you need something like this, because if it's a possibility that your own users are even malicious or possibly even just unlucky and press the wrong button sometimes, you of course would need to protect against the consequences of this. You would of course need some part of the system which will continue to work correctly even if the system is under attack from someone. So even if you think that it's quite a demanding assumption that some part of your system will always work correctly no matter what happens, it's actually quite a necessary assumption. So the important thing about the trusted computing base is that obviously, if it's too complicated, if it's too big to analyze, then the whole system becomes much more fragile. So the basic goal here is to keep it simple, keep it small, and also identify where it is. So one of the first reasonable steps in analysis of a system would be to say, okay, in the system, which parts of it would I identify to be part of my trusted computing base? And once I've seen what those are, is it actually a believable assumption that these things will always work correctly as they should? So it's also important to realize that the trusted computing base most likely will not be a single entity. It will almost always be a combination of different parts of your system. It can be software parts, it can be hardware parts. It could, for instance, the OS kernel is very often a part of it, actually always is a part of the trusted computing base, because that's usually, for instance, where decisions are taken as to when this user wants access to something, does he get that access or not? There's also something we talk a lot about later on today, which is firewalls, which would be entities, either software or hardware entities, that would sit between the system and the evil internet out there and would decide which traffic you allow. But this is a very important part of your system security as well. And there will be, lots of other parts like this. So the takeaway message from this part here is, when you're talking system security, first step, figure out which parts of your system make up the trusted computing base, and do you really believe that those parts are as trustworthy as they should actually be? Right. So in some sense, all of what we talk about in this section of the course will be about different parts of the trusted computing base, how to design it, how to think about it, and how to make these parts be as secure as possible. So we'll start with this thing here, the firewalls, and here just to motivate why we are talking about firewalls. So here is our in-house system, and out here we have the evil and wild internet, the jungle where everyone can try and communicate with everyone. And if you have a connection outside, which I mean, of course you usually do, then the question is, what can happen if the bad guys out here, let's draw a bad guy here, if the bad guys out here try to communicate with machines on the inside and try to hack their way in. So to prevent this, you might naively think that, you know, that's fine. We will only talk we'll not talk to the bad guys. We'll only talk to nice people that we know who are, and we know how to establish secure connections. So we'll simply take, you know, if we have a good guy here, we will simply establish a secure connection with this guy and make sure that nobody else can break into this connection. And so we should be fine. Okay. Well, the problem is it doesn't quite work like this, right? Because such a secure connection has to be set up. This is one thing. And what that means is that when this connection starts being set up, then somebody from the outside asks for this connection. And at the point where this happens, you really don't know who you're talking to. While you are doing the authenticated key exchange, that will probably be part of this, then you find out who you are talking to. But earlier in the process, you actually don't know. So even if you insisted on only using secure connections, there will be some point in time where your machines on the inside need to talk to people that you have no idea who are. And of course, also, in addition to this, most companies will have a web server whose purpose, of course, is exactly to talk to anyone. That's the whole idea. So you will need to, I mean, the idea that we can just cross out this bad guy here is actually too naive. We really have to face the situation that we will be talking to the bad guys out there. So this means that we will be under attack. No matter what we do, that there'll be people trying to hack into our machines using overflow attacks and the like, which we'll talk about later on in more detail. And so the question is, how do we minimize the risk of such hacks happening? And the firewall is just an embodiment of a really simple idea. So a firewall is an entity that you place here. That's the firewall, such that physically communication from the outside has to go through the firewall to reach the inside and vice versa. And the idea is quite simple. You cannot hack into a machine that you cannot communicate with. And so if the firewall can stop as much as possible unwanted traffic, then you minimize the risk of the bad guy out here getting to talk to a machine that he might be able to hack into. So in order to look at what might a firewall do, we need to talk a little bit about the structure of the traffic that you will see on the net. So one of the two, there are two main protocols on the net that's being used. One is called UDP, and the other one is TCP/IP. Most of what you see out there will be running via one of these protocols here. So UDP is basically well, a very simple protocol in some sense. You send a packet, and then you hope for the best. So in UDP, there's no notion of a channel that you establish. There's no notion of resending a packet if it doesn't get there, and receipts and stuff like this. You basically just send out a request to a server, say, and then you hope that it will actually respond at some point. If it doesn't happen, you have to try again. So a primary use of this will be to talk to DNS servers. So in other words, if you want to translate an IP address that I can type as a human into an actual IP address on the net, then you'll be calling a DNS server to make that translation. But there are also lots of other uses, like, you know, streaming of movies and stuff, legal or illegal perhaps, and stuff like this. So here in TCP/IP, on the other hand, you have a notion of a channel, and you have a setup. So the idea is that when you communicate on TCP/IP, you first have to establish a channel, and there is a certain handshake that you do to do this. And the important thing here to notice is that those network packets that do the handshake can be identified. So, and in general, all the packets that are being used, be it UDP or be it TCP/IP, have sender and receiver addresses that you can read if you look at the traffic. So the idea is that we can ID. Sorry, that didn't make any sense. So the important observation is we can identify a number of things, both the protocol, the sender, and the receiver by their IP addresses. We can also identify the ports. So this is a notion that says if you are a packet that wants to talk to the web server, for instance, that so it has to do with HTTP traffic, there's a certain port number inside the packet that will tell you that this is what's happening. And there's also certain flags in TCP/IP packets that allows you to identify a packet as being part of this handshake protocol that tries to set up a connection. So you can identify that a certain packet is part of a connection setup. Okay, so what this means is that if you place yourself in the middle here, so if the firewall is sitting right there in the middle, what it can do is it can look at traffic and see, is someone out there trying to set up a connection, for instance, with a machine on the inside, and what is the purpose of the connection? Is it trying to talk to the web service, trying to talk to somewhere else, and then make a decision based on this, on whether it wants to allow this sort of thing. So this allows us to talk about different types of firewalls. So the first part, the first really simple type is what is known as simple packet filter. So packet filter is simply a machine or a piece of software that sits there. It looks at every packet that comes by, and according to a certain set of rules, it will decide whether that packet gets to pass or that packet is blocked from passing. And this applies both, of course, to packets coming from the outside or packets coming from the inside. So you block or allow each packet, and there will be a bunch of fixed rules that tell you what to do. So this way, for instance, you could say no machine from the outside gets to open a TCP/IP connection, so any machine on the inside. Or you could say UDP is not allowed because I think people are going to use this for dodgy purpose like movies and stuff like this. The problem, though, is that if you start being very restrictive, then you also will block traffic that you actually need to allow. So so the caveat here is that you probably, or not probably, you must allow for DNS queries. And this means that some UDP traffic has to be allowed. And there's also a business of access to your web server if you have such a thing in your system. Of course, I mean, the whole purpose of the web server is that you want people to talk to it. And so you have to allow, of course, access to that thing. So the I guess take-home message here about the packet filter is that this thing is so simple-minded that either if you want it to be secure, it's going to be very, very restrictive and probably block traffic that you actually wanted to allow, or if you allow all the traffic that you need to get through, then most likely it's going to be full of holes. So a packet filter is usually not the only answer to all this stuff. You need to filter traffic in a more intelligent way. So we come to the second type, a very radical approach to intelligent filtering, which is known as a proxy firewall. So basically a proxy firewall. So proxy relates to the idea of doing something on behalf of someone else. And that's exactly what a proxy firewall does. So again, if we have our in-house system here, and here's a machine that wants to talk to the outside world, here's the firewall. And out here in the internet, there is some service here, some web service that this client in here would like to access, let's say. And normally, if there was no firewall, the client here would simply open a connection to the service out here. But the proxy firewall will say, no, you cannot do this. Nobody gets to make a TCP/IP connection to anyone except me. So if you want to talk to anyone on the outside, you have to open a connection to me. So there's one TCP/IP connection there, and then I will open one to the service out here on your behalf. Okay, and same for the outside. If anybody wants to connect to the system here, there is no way to connect to anyone on the inside directly. You have to make a connection to the firewall first, and then it might allow you to talk to the inside machine, but it will open a connection for you to the inside. So, so security with such a setup is really very, very good in a sense, because anyone on the outside, in principle, can only see the firewall. Okay, because you really can't talk to anyone except this guy. So this is where the center of security is. It can be hard enough, of course, to make one machine very hard to break into, but at least that's easier job than having to, secure every machine on the inside here. On the other hand, flexibility is not so good, right? Because the problem, of course, is this client machine here on the inside that wanted to access to the web service from before. Obviously, it has to know how to use a proxy to get through here. If it insists on connecting directly to the service, then you're out of luck. You can't do anything. You might be able to make a special modification to the firewall. If you could make the client here believe that the service is actually located at the firewall, then the client would connect there, and then the firewall would kind of translate the traffic into traffic on the outside to the actual web service. So this means you have to make a special implementation inside the firewall for every process in here that doesn't know how to use a proxy. So that's quite a job. And every time there's a new version of something, then you have to go and implement once again. So even the proxy firewalls definitely are very secure. They're very often not used because you get all this trouble with setting up things and making stuff work. So therefore, the last type is probably the most used, namely something called a stateful firewall. And a stateful firewall is something like a packet filter, but with more intelligence. So the idea is that, again, we have our inside system here. We have the firewall here, which is now bigger because I need some more space. And we have the internet out here again. And the idea is then that every time somebody, either from the inside, from the outside, wants to open a connection, then if this is allowed, there will be a connection. There will be, say, a TCP/IP connection to someone on the outside here. But the firewall will remember. So there will be a table that says table of connections. So the firewall will remember that this connection was established. So this was connection number one. There'll be an entry here in your table that says who are the parties that talk to each other. And then further, when some packet comes along that belongs to this connection, you can actually identify, does this packet actually belong to the connection that was open, and then allow it if that was the case. And if a packet does not belong to any connection that you allowed to be opened, then you can drop that packet. This clearly allows you to be much more intelligent in your decisions. So the big difference between a stateful firewall and the stateful packet filter is exactly the state, the memory that you have, so that you actually know more about what is going on. You also have the possibility, because you have this the state, this memory of which connections are open, to do a little bit more interesting stuff here. For instance, what you can do is something called network address translation. And the idea is that sometimes you would actually like to hide the IP addresses that exist inside your system here, because what many adversaries do is they do something called port scanning, which means that they just go through a whole range of network addresses and try to send to all these addresses in the hope that maybe someone on the inside actually has one of these addresses and will respond, and then maybe you can start an attack. So if the adversary doesn't actually know what addresses are used on the inside here, then that attack would be made much harder. So the idea of network address translation is that this table here will contain both, if you have an address here on the inside, that's address number 1, that would be in the table. But then, in fact, the firewall will invent a fake address. So that would be address number 2, which it will, when this connection is open from the inside to the outside, let's say, the firewall will tell the outside world that the machine opening connection is at address number 2 here, and this address, of course, doesn't really exist anywhere except in the mind of the firewall. But on the outside, you cannot see this. So it means that when you try to do port scanning or something from the outside here, you will not know which range of addresses to target in the attack. And this can be an advantage for security. So, of course, all this stuff is only possible because the firewall is there. It has this table that it remembers. So whenever a packet comes along, it can translate the packet, the address in the packet, from the outside address to the inside address. Okay. There's also something called stateful inspection you can do. This is an idea that is again related to the fact that you know which channels are open. So if you can identify which packets belong to this channel here, this connection here, then you can start looking at how does the traffic behave on this channel. Is there some strange thing about the behavior? So, for instance, one example of this is when you have a web server on the inside here that's talking to a client on the outside, then say the web server has some form that the user should fill in, and then many attacks actually consist of putting fake content into these forms. So fill in a much longer string than what's actually supposed to be there. And if you watch the traffic as a stateful firewall, you might be able to detect unusual behavior like this and maybe drop the connection. Okay, so that's basically the 3 types of firewalls that we have, roughly speaking. I think one remark on this that is maybe the final take-home message here is that maintaining firewalls is a really important task. So it's important to remember that installing a firewall and then just forgetting about it is not going to be good enough usually. And this is simply because in real systems, the configuration of your inside system changes always over time. New machines are added, new functionalities are added. And what the firewall is supposed to allow obviously needs to depend on this configuration that you have. So it's really important that someone in your organization is responsible for making for taking charge of the firewall and making sure that it lives up to the current configuration that is inside your system. Okay. So that was the end of this lecture. Next lecture will focus on systems for intrusion detection and malware.